Bismillahirrahmanirrahim. So, dear students, today we will start our another chapter in the inorganic chemistry portion, and that is your organometallic chemistry. So, let's begin with our organometallic chemistry. So, today we'll be talking about the definition of organometallic compounds and classification. So at the end of this class, you can easily download this note. So it's a very concise note. You can use it for the exam purpose. So the link will be in the description. So let's begin with the definition. So definition of organometallic compounds. Organometallic compound can be defined as the one that possesses a metal carbon bond. So those compounds which contain a metal carbon bond. The term organometallic compound generally it refers to those compounds in which the organic groups means those groups which are organic like CH3, CH2, ethyl, so which contain carbon. They are called the organic groups. They are directly linked to a metal. So we have metals in the periodic table. So if you have the organic group which is directly linked to the metal, so those compounds are called organometallic compounds. So there should be at least one carbon atom. So at least in that particular compound there should be one carbon metal bond. So the bonding is ionic. Now these organometallic compounds, this bond, this can be ionic or covalent, or it can be delocalized between the organic group and the metal. Okay? Now examples. First type of example is a symmetrical type of example. For example, dimethyl mercury. You can see here this is basically like this. You have mercury here at the center, and then this is attached to C2H5 group on this side, that is your ethyl group, and on the other side also you have the ethyl group. Since both the sides the groups are same, so it's called as the symmetrical organometallic, and you can see here the metal carbon bond. So this CH2 is organic part and mercury is metallic part. Likely examples can be unsymmetrical. For example, ethyl methyl mercury. So this side you have ethyl part and this side you have methyl part. So this is unsymmetrical organometallic compound. Then there can be mixed organometallic compounds in which a metal atom bonded with more than one identity of organic or inorganic constituent. For example, you have a compound where we have this type. Magnesium is a metal at the center. On one side it is attached to the inorganic part, that is the boron. So this bromide, and on the other side there is ethyl group. Now ethyl is an organic part and then this is an organic part. So this type of compounds are called as the mixed organometallic compounds. So this is with the definition. Now let's look at the classification. Now classification, there are many types of classifications. I have made it very simple so that we should understand the basics at this level. So they can be classified into the ionic bonded organometallic compounds and covalently bonded organometallic compounds. Ionic bonded. The organometallic compounds of alkaline earth metals, lanthanides and actinides, they are predominantly ionic compounds. So those organometallic compounds where we have metal as alkali metal, alkaline earth metal, lanthanide, actinide. Now in these cases the bond between the carbon, the organic part, and the metal is predominantly ionic in character. Okay? Now these compounds are usually colorless. They are extremely reactive. They are highly reactive. They are non-volatile solids and they are insoluble in the organic solvents. For example, you can take these two examples. Remember at least these examples. For example, cyclopentadienyl calcium. Now what is this cyclopentadienyl? What is the structure? This we'll see in the upcoming classes. And this is your triphenyl sodium. So these are the two examples. Then if we see the covalent bonded organometallic compounds, they are further of two types. One is the sigma bonded organometallic compounds and pi bonded organometallic compounds. Now in sigma bonded organometallic compounds, they are the compounds in which the carbon atom of the organic ligand, means the CH3, CH2, it is bonded to the metal by a 2 electron 2 center bond, which is a covalent bond. And normally the covalent bond which we have between the two atoms It's called as a two center two electron covalent bond. Okay? Generally formed by most of the elements in the value of electronegativity are higher than 1. For example, we have a compound here, tetracarbonyl nickel, very famous compound which is used in the Mondes process, and then pentacarbonyl iron. So if we see here, the bond is between the carbonyl part as an organic part and then the iron as a metal. Now, likely in this case, we have a bond between nickel and carbonyl. So iron and carbon, if you see this, iron, its electronegativity value, so it's found in most elements where the electronegativity values are normally higher than 1. So these are called the sigma bonded organometallic compounds. Means this bond between metal and carbon or metal and organic part, it's more of a sigma bond. Okay? Now if you see the pi bonded organometallic compounds, so this is formed by alkene, alkyne or some other carbon group which has a system of pi orbitals which overlap with these with the vacant orbitals on the metal. So metal has the vacant orbital. For example, I will see one example here. You have iron here. So metal has a vacant orbital available. Now with that vacant orbital, we have this ligand, cyclopentadienyl ligand. So cyclopentadienyl is a kind of ligand where we have two pi bonds and then you have negative charge here. So these 5 carbons, they overlap with this vacant orbital of the metal. So this type of bonding exists here. Likely यहाँ पे दूसरी ring. So we have another ring on this side, cyclopentadienyl ring. Now such bonds, such compounds of organometallic compounds are called pi bonded organometallic compounds, because here the ligand is like an alkene or it is alkyne or it is any type of ligand which can make multiple, at the multiple locations it can bond with the metal, because metal has the vacant orbital and that vacant orbital overlaps with these delocalized pi electrons. So for example, the best example we have cyclopentadienyl iron and we have this Z salt, potassium trichloride ethyl, which is Z salt. So Z salt is PtCl3 and then we have alkene at the 4th position. Now these compounds we'll read deeply in the upcoming classes, so that's why I'm not discussing here the structure. And this is your cyclopentadienyl iron, which means the ferrocene. So you can at least remember these 2 examples for the examination purpose, and then the rest, what is the structure of these and how it is bonded, what are the properties, those we'll see in the upcoming classes. So till then we have the classification. So organometallic compounds can be classified as ionic bonded organometallic compounds, where the metal carbon bond is ionic. Example, this is your triphenyl sodium and cyclopentadienyl calcium. And then sigma bond organometallic compounds, where we have a sigma bond, that is 2 electron bond between the metal and the carbon part. And then pi bonded organometallic compounds, where there is a pi bond or the ligand is alkene, alkyne or any size type of ligand which can coordinate, or we can say which can bond with the metal through multiple positions. So this we will further see in the upcoming classes. So this was our today's class regarding the definition of organic metallic compounds, examples, and then the basic classification of ionic and covalent bonded organometallic compounds. So if you have any question, you can easily write down. You can put up in the comments. So thank you.